Hello everyone. In today's video, we are going to solve one problem on Bernoulli's principle. So let's have a look at the problem. Now, this is a problem in front of you. Now, if you are already aware of how to solve the problems on Bernoulli principle, you can try this problem. Now, let's start with the solution. First of all, this problem is based on the flying of an aeroplane. You must be knowing that the lifting of the aeroplane on the runway can be explained on the knowledge of Bernoulli's principle. So this question is based on that. First of all, we will draw the diagram to understand the situation. Let's see the diagram first. Now, see, suppose this is a cross-section area of the aeroplane wing we have shown. So this is a wing of an aeroplane. This is a front side of its wing. Now suppose this aeroplane is moving on the runway, so the wing of this aeroplane will cut the air present on the runway. Suppose here air is present, this air will be cut by the wings. So some air will flow above the wings like this, and whereas some air will flow below the wings. This way. Now the air which flows above the wings, it has a velocity of 60 meter per second. That I am writing as a V1. And suppose the pressure exerted by this air on the wings, the pressure is, let's say, P1. Similarly, the air which is going below the wings, this air has a velocity which I am calling as a V2. It's 40 meter per second, and the pressure that this air exerts is, let us suppose, P2. Okay. Now, the design of the wings of an aeroplane is in such a way that velocity above and below is different. Now, the side where velocity is more, that side pressure is always less. It is as per Bernoulli's principle. So, velocity on the upper side is more, that is 60. So, pressure on the upper side would be less. P1 will be less than P2, in fact, here. P2 will be greater than P1. Okay. The side where velocity is more, that side pressure would be less. It is as based on Bernoulli's principle. So now here, if we apply the Bernoulli's principle, we can write it down as P1 plus half times rho V1 square. This rho is a density of the air. It's equal to pressure lower, that is P2, plus half rho times V2 square. Okay. This is Bernoulli's principle I applied. Now, from this, as I said, P2 will be greater than P1. The side where velocity is less, that side pressure is always more. So from here we can adjust this way, that we can write P2 minus P1, we can adjust, equals to half times rho V1 square minus V2 square. This way we can arrange this equation. Okay. Now, just we have to substitute the values. Half rho, that is density of air, it is given 1. V1, it's 60 meter per second. V2 is 40 meter per second. And from this you will get P2 minus P1. So just solve it. It is like 3600 minus 1600 into half. It will give you pressure difference, P2 minus P1. Now when you multiply pressure with the area of the wings, that becomes the net force. If I multiply both sides by area of the wings, this way. This A is the area of wings. Pressure into area of wings. Remember, if you multiply them, this becomes the force from the top, and force from the bottom will be P2 into area of the wings. Okay. So pressure times area will give you, right, force. So this P2 minus P1 into A, this becomes the net dynamic force on the wings. Okay. So just we have to solve this one. Now area of the wings is given in the question. If you see, it's 10 meters square. So we have to put this area as 10 into half. This is 2000 Newton. Okay. So you will get the answer as 10,000 Newton. So this is nothing but the force of dynamic lift acting on the aeroplane wings. Because of this force only, the aeroplane takes off in the air. Okay. So I hope this problem is clear to you. If you have any doubts in this problem or related to physics, you can give me in the comment section. I will try my level best to explain that doubt to you. Okay. So I hope this problem is clear to you. We'll meet in the next video now.